Calculate the number of molecules in 2.0 kilograms of N2. In this case, we will solve the problem using two techniques, the chemical conversion factor and algebraic theorems. We will start with the chemical conversion factor. The first step is to write the given data in the format of the chemical conversion factor, where each term consists of a value, a unit of measure, and a substance identity. In this case, we have 2 kilograms of molecular nitrogen. Then, we multiply by the first conversion factor, which involves placing kilograms of nitrogen in the denominator and grams of nitrogen in the numerator. Since the kilogram is a larger unit, we establish that 1 kilogram equals 1,000 grams, or, more elegantly, 10 to the power of 3 grams. In the second conversion factor, we place grams of nitrogen in the denominator and moles of nitrogen in the numerator. Here, we assign the theoretical unit to the mole and determine how many grams are in 1 mole. The answer to this question is the molar mass. By calculating the molar mass of nitrogen, we know that each nitrogen atom contributes 14.01 grams per mole, and since molecular nitrogen, which is dinitrogen, contains 2 atoms, the result is 28.02 grams per mole. In the next conversion factor, we place moles in the denominator and molecules of nitrogen in the numerator. Again, the mole carries the theoretical unit, and the number of molecules in 1 mole of any substance is always Avogadro's number, which is 6.022 times 10 to the power of 23. In the dimensional analysis, we eliminate the units and the ones that multiply and divide. If any unit has significant figures, they must be taken into account. We extract the significant values to input them into the calculator, and the result is 4.3 times 10 to the power of 25 molecules of molecular nitrogen. To apply the theorem, we select the corresponding one from our formula sheet, which states that the number of molecules, represented by J, is equivalent to the product of Avogadro's constant times the given mass, divided by the molar mass. We simply follow the equation. In the formula, we substitute J for the identity of the substance, which in this case is the molecular formula of the substance. Then, we substitute Avogadro's number with 6.022 times 10 to the power of 23 in units of 1 per mole, the mass with 2.0 kilograms, and the molar mass with 28.02 grams per mole. Additionally, we replace kilo with its definition, which is 10 to the power of 3. Note that in this method, the identity is contained in the dependent variable and does not need to be included in the operational terms. When performing the dimensional analysis, the units cancel out, which makes sense since algebraically, the number of entities is a dimensionless parameter. This differentiates it from the form of conversion factors. By eliminating the ones, we find that the significant terms are the same as those generated by the conversion factor, so the value is the same, 4.3 times 10 to the power of 25. In this case, it is understood by the italicized capital N of the theorem that we are talking about entities of dinitrogen. Since dinitrogen is a molecular substance, we implicitly refer to molecules without the need to express it with units and identities as done in conversion factors. Since the only actual data is 2.0 kilograms, we count only 2 significant figures, and the answer is given in 2 significant figures. Well, that's all for now. If you enjoyed the presentation, Don't forget to subscribe, like, and share. It keeps this channel alive. See you next time.